So I'm not positive at what stage you're watching this video. Hopefully you've done a little bit of probability, where you've done permutations and combinations. And we do combinations a lot with probability. And because we come across them a lot, we kind of have a quick summary of what all these common combinations might be. And so you can see here, this is a notation 0, choose 0. It can be written like this also, so you may be familiar with that notation. This one right here would be combinations of 3, choose 2. Whichever way that you want to write, that doesn't matter. But what this is kind of a display of, just in a very organized way, of all these very common combinations, starting with 0 items and you choose 0, all the way down to, if you had 5 items, you could choose 5 or 1 or 2 or 3 or 4 or 5. Okay, so Blaise Pascal, mathematician, he did a lot with probability, so he used these a lot. So he made this nice little chart, and so he called it Pascal's Triangle. And he evaluated all these different combinations and made this triangle. It looks like this. All right, so 0, choose 0 is 1. 1, choose 0 is 1. And 1, choose 1 is 1. And that we call that the first row, 0 row, and then the first row. The second row is a 2, choose 1, 2, choose 0, 2, choose 1, and and 2, choose 2. And then again, just filling out this triangle of all these different possible combinations. If you type them in your calculator, these are the numbers you would get. Blaise, of course, did not have a calculator. He did this in his head. Okay, now as you're building this Pascal triangle, there's actually a shortcut to it. You start to get familiar with it, and the first number is always a 1. The second number is always what row it is. So this is the 5th row. Again, it starts at row 0. But also, these two numbers added together always give you this number. So then this would be a 10, and then a 5, and then a 1. And you can see that happening up above. Also, a 2 and 1 gets you a 3, or a 3 and a 1 gets you 4. All right, I'll do one more row. This is the 6th row. It goes 1, 6, 15, 20, 15, 6, 1. All right, so this is called Pascal's Triangle. You may be familiar with it. All right, so moving on. Later on, Isaac Newton did work with binomials, where he was taking them to a power. So you can see here that you have a lot of different binomials, to the first, to the second, to the third, to the fourth, which means he wrote it out, and foiled it out, combined like terms, and then this is maybe what he ended up with right here. All right, which is, if you look at it, there's a 1, 4, 6, 4, 1, and he recognized that, hey, those are just the numbers from Pascal's triangle. The coefficients on these terms end up being from Pascal's triangle. So maybe he doesn't really have to FOIL this out 5 times if he already knows what those coefficients are going to be. In addition to knowing what that number is, look at what happens with the other terms. When you take this term, let's say to the 5th, the very first one is an a to the 5th, and then you can see the a power works its way down until it's to the 1st, and then it's to the 0 where it's actually gone. Whereas this second term starts off and it's not there because it's to the 0, and now it's to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th, and it works its way up. So there's like 3 parts to every term. There's that coefficient from Pascal's triangle, and then there's your first term raised to a power and your second term raised to a power. So with that nice little pattern, Newton came up with what's called the binomial theorem. So if you take a binomial and you raise it to a power, it is the sum. You may or may not be familiar with that. Capital sigma means the sum of a whole bunch of terms. And those terms are that combination from Pascal's triangle. And then it's your A, which is that first term, written to a power, and the B written to a power. Now, I don't know that we got to get too caught up in this formula. It really just follows that pattern. Let's go ahead and just try some. I think you'll get the hang of it. All right, so we have an A plus 3 to the 5th power. So here's how this works. I am going to, because it's to the 5th power, I'm going to use the 5th row of Pascal's triangle. And you can peek back at what the fifth row of Pascal's triangle was. It was a 1, 5, 10, 10, 5, 1. Oops, sorry, I missed. Is that right? Yeah, that was right. All right, so now what I'm going to do is I'm going to take the very first coefficient, that's a 1. Then I'm going to take my a, which is my first term, and I'm going to raise it to the highest power. And then I'm going to take it times the 3 raised to the lowest power. And that right there is going to end up being my first term. So I don't have to FOIL this out a whole bunch of times and distribute and combine like terms. I'm not doing that. I'm just going to jump straight to what the answer ends up being. All right, so the second term, after I would have done all of that, would get me a Pascal number, coefficient there of 5. And then my a is going to work its way down, so now it's to the 4th. While my 3 works its way up, it's now to the 1st. My next term, pulling from Pascal's triangle, I'll have a 10. A is going to be raised to the 3rd power, while 3 is going to be raised to the 2nd power. Plus, let's do it again. The next Pascal number is a 10. A working its way down, B working its way up. Plus, then I have a 5. A continuing to work its way down, B working its way up. Last term, I have a 1. My A will be to the 0, while my B will be to the 5th power. Now I said we're just going to write the answer. Well, we're going to want to clean this up because you can combine some of this stuff. There's a couple number parts. You have the Pascal number and you have the B value on this example. Those are just numbers that can be combined. So I have a 1 and I have a 3 to the 0. That's all just 1. So my first term would end up a to the 5th. Plus, now I have a 5, but I also have this 3 to the 1st, and I'm just multiplying these things, and 5 times 3 is going to get me a 15, and then I'll have an a to the 4th power. Plus, I've got the 10, and I've got the 3 squared that are being multiplied. That's going to get me a 90, a to the 3rd. Plus, now I have a 10 and a 3 to the 3rd. 3 to the 3rd power is 27, so times 10 is 270. My a is now squared. Plus, now I have a 3 to the 4th power here. Do you know your powers of 3? 3 to the 4th times a 5. 3 to the 4th is 81, and 81 times 5 is 405. And now I'm just down to an a to the 1st, plus, and on this next one I have a 1. The a to the 0 is going to end up going away, and I just have a b to the 5th, which is going to be 243, I believe. Sorry, let me fix that. I had written b to the 5th because I was saying the b to the 5th. I was saying the b because this b term was now a 3. I kept saying, because this is your first term, your a, this is your b, but the b is actually a 3. I hope that wasn't confusing. Sorry. That was referencing the previous. All right, so really this is a 3 to the 5th, and that's 243. And that right there, ladies and gentlemen, is what we would get without having to FOIL this all out and combine like terms and hopefully not mess up a sign or any of that kind of stuff. So, all right, let's try another one. Okay, so now again, I kind of referenced this as my first term, like this is my A term, this is like my B term. I made this one a lot fancier. We're not going to go as high a power, but I did throw a coefficient on the front end this time. They might both have coefficients. I put in a minus sign, and I made a quantity be squared within that parentheses set. So a lot of different kinds of things can happen. The process is the same. Now I'm taking this to the 3rd power, so I have to know the 3rd row of Pascal's triangle, and that's a 1, 3, 3, 1. So my very first term will be a 1, and then I'm going to take this 2x, and I'm going to raise it to the highest power. So in this case, since we're cubing it, it'll be to the 3rd. And then I'm going to take this negative y squared and raise it to the lowest power, and that's a 0. So those are the 3 things I've got to deal with, and then I put a plus sign, and then I write it again. Now I do like to use these parentheses here and try to tuck these 3 things all together so that then you have like this plus and you're ready for a new term. Kind of separate this because you don't want this minus sign to start looking like you're subtracting in the midst of that. So those three things are always being multiplied. So now I pull Pascal's number, it's a 3. I take the first term to the next power, so it's going down, so now it's squared. And then I'm going to take the negative y squared, and I'm going to work its way up, so it's now to the first. Plus Pascal's number, 2x is now to the first power, negative y squared is now to the second power. Plus one more term, I've got a 1. The 2x is now going to be to the 0, while the negative y squared is to the third power. Now we write that, and now we're kind of cleaning it up and multiplying what I can. So when you look at this first one, I have this 1, I have a 2 cubed, and this whole thing is to the 0. So that's going to go away, and I'm just going to have this 8x cubed. All right, on my next term, I have the 3, I have a 2 squared, but I also have this negative. Think of that like a negative 1 raised to the first power. So that is going to end up being a negative. So I'm going to have a 3 times a 4 times a negative 1. That gets me a negative 12, and then it looks like the x will be squared. And the y has a power on it also. It's going to be now squared as well. All right, so let's go to our next term. So we've got a 3, we have a 2 to the first, and this time the negative 1 that's assumed to be right here is being squared, and so that squared is going to make it go back positive. So since it's positive 1, it doesn't really affect my numbers. I'm just going to have this 6. I will have a plus 6. My x is to the first, but notice that your y was squared and then it's squared, so that's going to be y to the 4th. All right, last term. Here we go. I've got the 1. I've got this entire term raised to the 0 power, so it's going to go away. This negative is now being taken to an odd power, so I'm back to getting a negative value, and y squared cubed would end up being y to the 6th power. So I'm left with a negative y to the 6th for that term. All right, so a couple things that I want you to notice about that one is that because it was a minus sign, let's even go back to the term before it, the one before it up here. If this is a plus sign, notice everything stays positive. There's no place to introduce a negative. If it happens to be negative, then what's going to happen are these are going to alternate, because this was positive, now it's negative, now it's positive, now it's negative. That's going to happen because this power is going to alternate even and odd on that negative that gets set there. So kind of be looking for that to happen. The other thing that I want you to always notice here, another pattern, is that these powers right here will always add up to whatever that power is. So you can see it's a 5 and a 0, a 4 and a 1, 3, 2, 2, 3. These always add up to that power. Same thing here. Now it starts to change because now when you get down to this last step, it all depends on what's inside there. When you get down to that last step, those powers start to change because I had that squared in there originally. So you can see now that these don't necessarily add up to 3 anymore, but there should be kind of a pattern that goes in the very first set of work. You should notice that those add up. All right, I'm going to call that good. If you need to rewatch, maybe that first one was a good one that kind of had a lot of stuff going on to it. But I want to introduce you to one other type of problem. These problems do take time to do, and so I can't ask you to do a bunch of them. Sometimes I just need maybe just one term of the whole mix. Could you tell me what the coefficient on just one of them is? So here's my example. It says find the coefficient. So I just need that number of the x to the 4th term in this expansion right here, 5x plus 2 to the 7th power. All right, let's peek back. Okay, I wish I could have just like screenshotted that and brought it back, but I couldn't, so I just rewrote on that previous slide. Okay, this was how that first one was broken down. And what I want you to notice here is this Pascal number, this 1, 5, 10, 10, 5, 1 that we had. Remember that that's going to be the 5th row of Pascal's Triangle. And so that 1 actually is coming from the combinations of 5, choose 0. This 5 would have been 5, choose 1. This 10 would have been 5, choose 2. This one would have been 5, choose 3, and on and on. And that's where those numbers came from, recall. All right, well, if I want to pick just one of those terms, then I know that it's going to be a combination of, in this example, it would be a 5, but in these others, it all just depends on what the power is. It looks like this one's actually going to be a 7. This one down here is going to be a 10. But this is it from the previous slide, this thing here. So I know it's going to be 5, choose something, but what is it going to be? 5, choose what? How do I know where that's going to fall? Well, I want the x to the 4th term. If you think about that, if the x is the first term, and if it's going to be, well, in this case, to the 4th, remember that these two powers up here always have to add up to that total. So I'm going to do this in a different color off to the side, and this is really this particular problem. I have a 5x plus 2 to the 7th. So that means that I'm going to end up with that first combination. It's going to be combinations of 7, choose something. I'm not 100% sure what yet. We'll come back to it. And then I know that I'm going to have this 5x that has to be raised to some power. And I'm going to have this 2 that's raised to some power. Now, because they're asking for the x to the 4th term, I know my x better be raised to the 4th power. And remember that those powers have to add up to your overall power. So this 2 better be raised to a 3 so that they'll add up to 7. And then if that's a 3, remember that that's going to then match, so it's a 7, choose 3. So this right here, I can get just one of the terms done without having to do the whole string. So then I would go to my calculator and I would type in 7, choose 3. You can find that in your math menu. And then you go over to probability, and it is number 3. Now, depending on your calculator, if you have one of the nicer color calculators, you do that, and then you fill in the boxes 7 and 3. If you have kind of an older calculator, what you might have to do is hit the 7, then go to the math, probability, the combinations, and hit that, and then hit your 3 afterwards. It depends on the calculator. But if I do that, I get a 35. So I know that that part of my answer is a 35, but it's also getting multiplied by a 5 to the 4th power. 5 to the 4th power is 625. And then I also have this 2 to the 3rd power, which is an 8. I don't really have to have, they're only asking for the coefficient, so I don't really include the x as part of my answer. I'm going to go ahead and multiply those 3 numbers together. 35 times the 625 times the 8. All right, if I were to have FOILed this out, it would have gotten pretty messy to the 7th power, and this one particular term would have a coefficient of 175,000. That's the answer they want, just the coefficient on the one term. All right, let's try that. Now that we know how that pattern works, it really should go pretty quickly for us. I don't have to redraw everything out. Here we go. Find the coefficient of x to the 3rd, y to the 7th. So I'm doing this quantity to the 10th, so I'm going to have combinations of 10, choose something. I'm going to have my 2x raised to some power, and I'm going to have my negative 3y raised to some power. Now it says right here that x needs to be raised to the 3rd power, so I'd put a 3 here. And you may wonder, like, what about the y though? Well, remember that these powers have to add up to 10 in this case, so that's going to be a 7 anyway. This, whatever I give you here, it's going to fall into place perfectly. So those add up to 10, so those got to be my powers, and the 7 is going to be the match down here. So then I type in my calculator the combinations of 10, choose 7, get that value. It's a 120. Now I'm doing this in parts. You really could just do it all together in one shot in your calculator. 2 to the 3rd power is an 8. And a negative 3 to the 7th, it's an odd power, so I know that it's going to end up negative. And 3 to the 7th is 2187. Actually, it's going to be a negative 2187. All right, so then if I multiply those all together, I have this crazy huge coefficient of negative 2099520. All right, so rather large coefficient there. All right, so that's kind of the SparkNotes version of the binomial theorem. Hope this helps.